Bismillahirrahmanirrahim. For today, we are going to speak about the sample space and probability. We give some definitions in this part of this lecture. And we are going to speak about the sample space, what is the sample space, what is the probability, what is the outcome, and what is the event, and how to find the probability of an event. First of all, let's define the probability experiment. Probability experiment is a chance process that leads to well-defined results called outcomes. So it is just an experiment or a process of experiment that leads to well-defined, clear outcomes. Well-defined means the outcomes will be very clear, specific also. The outcome is the result of a single trial of probability experiment. We are doing this experiment for one time. What is outcome of this one will be, or what is the output will be outcome. So it is the output or the result of the experiment. We'll give this clearly after just a few seconds. Sample space is the set of all possible outcomes of a probability experiment. So we have probability experiment, we have outcome, and we have sample space. We are going to speak about these three words now. Find the sample space of the gender of the children if a family has 3 children. Let's see now what is the sample space and what are the outcomes. Now, for the family to have 3 children, what are the possible outcomes or gender that they will get? If we list all the possibilities, form a group or a set, we call this sample space. So the sample space is the set of all possible outcomes of the probability experiment. Now for this family, the first kid might be boy. They have 3 children. So I will have a couple of 3 kids. Second one might be boy. Third one is a boy. So this is one outcome. Now, second possible choice will be, the first one is boy, second one is boy, third one is girl. Or it is might be boy, girl, and girl. Or it might be the first one is boy, second one is a girl, third one is boy. Or might be the first one is girl, second one is boy, third one is boy. Or it might be the first one is a girl, second one is a girl, third one is a boy. Or it is the first one is a girl, second one is a boy, third one is a girl. Or first one is a girl, second one is a girl, and third one is a girl also. So this is the set of all the possible outcomes for a family to have 3 children. This is, we call it sample space. So the sample space is a set of all possible outcomes. Let's have another example. Find the sample space for rolling 3 coins. 3 coins. We know that the coin either will be head or tail. So the sample space in this case will be the first one might give me head, second one head, third one is head. So this is the first possible outcome. Or head, and tail. This is head, H for head, and T for tail. Or it might be head, tail, and head. Or it is head, tail, and tail. Or it is tail, then I have head and head. Or it might be tail, head, tail. Or it is tail, tail and head. Or it is tail and tail and tail. So it is 3 tails. So these are the possible outcomes of the rolling 3 coins, either 3 heads or minimum 2 heads, 1 tail, or it's just combination of the possible outcome for each one of them. And you can see that we have 8 outcomes. The number of the outcome usually is 2 to n, where n is the number of the outcome of the one experiment. Since I have coin and the coin has 2 faces, either head or tail, this is 2. 2 is the number of the faces of the coin, and n is the number of the experiment. And because I have 3 coins, so this is equal to 2 to power 3, which is equal to 8, which means that the outcomes will be 8. For this experiment, I have 8 outcomes. It is 2 to power n. 2 is the number of the faces for the coin, and n is the number of the experiment. We are doing this 3 times, 3 coins. For the next one, find the sample space of rolling 2 dice. This is dice, and for the dice we have 6 faces. And since we have 2 of them, so it is 6 to power 2, which is equal to 36, which means that I must have 36 outcomes. For the dice, we know that the numbers on the faces, they are 1, 2, 3, 4, 5, 6. The second dice also 1, 2, 3, 4, 5, 6. Now the outcomes or the possible outcome will be, the first one will give me 1, the second one also will give me 1. It will display 1. First one will give me 2, the second one is 1. Second one or the first one might be give me 3, second one 1, 4 and 1, and like this, 5 and 1, 6 and 1. Or first one will give me 1, second one will give me 2, or 2 and 2, 3 and 2, 4 and 2, 5 and 2, 6 and 2. And keep going doing this till the end. 1 and 3, 2 and 3, 3 and 3, 4 and 3, 5 and 3, 6 and 3. Then we have 1 and 4, 2 and 4, 3 and 4, and 4. 1 and 5, 2 and 5, 3 and 5, 5 and 5, and 6 and 5. Last one will give me 1 and 6, 2 and 6, 3 and 6, 6 and 6. So This set will be the sample space for rolling 2 dice. And you can see we have 36 outcomes. Giving the order of the first dice and the second one, so I will have 36 outcomes. So this is the sample space for rolling 2 dice. Sometimes we are using something called the tree diagram to list all the outcomes of the experiment. Tree diagram is a device consisting of line segments emanating from a starting point and also from the outcome point. It is used to determine all possible outcomes of a probability experiment. To explain this, let's have this example. Use the tree diagram to find the sample space for the gender of the children if a family has 3 children. Let's start with the starting point. Now the first kid either will be boy or girl. This is the first kid, number 1, the first kid. Now the second kid either will be boy or a girl. This is if the first one is a boy. If the first one is a girl, it is the same thing. I will have either boy or a girl. This is the second kid. Third one, same thing, will be boy or a girl. Now I have to do this for each one of them. Now I can write the combination of these. So I have the first one, boy, boy, boy. This will give me so this is the first outcome. Second one, boy, boy and girl. This is boy and girl. Third one, it's a boy. Now we are moving this way. So this will give me, starting with a boy, then we have girl, then we have boy. This one will give me boy, girl and girl. This combination will give me girl, boy and boy. This combination, it is girl, boy and girl. This combination is girl, girl and boy. And the last one is girl and girl, the last one. So this is the list of all outcomes of this experiment. And you can see we use the tree diagram to list all of the outcomes of the sample space. So this is another method to list all the outcomes of the sample space with the tree diagram. Starting with 1 point, and then in each, let's say, each experiment or each part of the experiment, we are doing the same thing. we are listing the possible from the start is boy or a girl. And then for each kid, the second or the coming one will be also have or has the two possibilities, either boy or a girl. So we are doing this till the third kid. Then we can list the combination of the outcomes for each case. So we are done from the listing the sample space or listing all the possible outcomes of an experiment or probability experiment. Now we can speak about something called an event. An event, it consists of a set of outcomes of a probability experiment. We mentioned the sample space and we said that it all the possible outcomes. If we take part of it, we call that an event. And we have two types of events. We have simple events that consist of only a single event, and compound event which consists of more than one event. Suppose that we are speaking about how many kids plus throwing a coin. So having a kid, this is one event, and throwing a coin is another event. If we combine these together, we call this compound event. So a simple event consists of a single event, but compound consists more than one. It might be two or three events. And we have two types of probability. The first one we call the classical probability, which uses sample spaces to determine the numerical probability that an event will happen. Classical probability uses sample spaces to determine the numerical probability, because we have another type called that empirical probability. So the classical one, we are using the sample space to find the probability of an event. Also, we have something called the equally likely events, and these are the events that have the same probability of happening. If we throw 2 coins, all of these outcomes are equally likely events. To have 2 heads or 2 tails or 1 head, 1 tail, all of these are or have the same chance to happen. We call this equally likely event. And the probability of any event E is divided by P of E equal to number of outcomes in E divided by the number of outcomes in the sample space. It is N of E divided by N of S. The probability of any event E is equal to N of E divided by N of S. Let's try to solve some example about this one. If 2 dice are rolled, then find the following probabilities. Getting double. Getting double, it means having the same number. It is 1 and 1. Two and 2. 3 and 3. 4 and 4. This means the getting double. It means we have the same number in the first one and in the second one. 5 and 5 and 6 and 6. So getting double, or the number of outcomes in this event. Now this is the event, getting double. This is E. I have 1 in the first one, 1 in the second one, 2 in the first one, 2 in the second one, 3 in the first one, 3 in the second, and this is the idea of double. So you can see that I have 6 outcomes. So the B of E in this case is equal to number of outcomes, that is 6, divided by the number of the sample space, the number of outcomes in the sample space. And 2 dice will give me 6 to power 2 equal to 36. This is the number of the outcomes in the sample space. It's 36, so that will be 6 divided by 36, which is equal to 1 over 6. So the answer for this one, or the property of getting double, is 1 over 6. So this is the idea of finding the probability of an event. It is the number of the outcomes in the event divided by the number of the sample space. More examples will be given in the coming part. I will stop at this point now, and I will give more examples in the coming part.